Welcome to part 2 of our videos about chapter 2 here. Okay, so we've got two kinds of questions I want to answer here. This will be much shorter than the last video. The first kind is a Chebyshev's theorem question. The one I'm picking here is slightly more complicated than the standard question. Let's get into it. For a sample with n equals 36, the n is the count, okay, the number of data points. The mean duration of a geyser's eruptions is 3.71 minutes. So it's a sample, so the symbol for the mean is x bar, 3.71. And the standard deviation, so the symbol they use for standard deviation for a sample is s, is 1.22 minutes. Using Chebyshev's theorem, determine at least how many of the eruptions lasted between 1.27 and 6.15 minutes. Okay, here's Chebyshev's theorem. Proportion of the data within k SDs, k standard deviations of the mean, is greater than or equal to 1 minus 1 over k squared. Okay, so k is the number of standard deviations, okay? That's the number of standard deviations away from the mean. Now, one thing to understand about these Chebyshev's theorem questions, the way this works, is that the numbers they're going to give you have to be balanced. In other words, the lower number is the same number of standard deviations below the mean that the upper number is above the mean. All right, so I'm going to start out by taking the z-score. I usually just use the upper number. Now, the formula for the z-score is the value you care about minus the mean divided by the standard deviation, right? Or sometimes they'll use mu for the, if it's a population, then they'd use mu for the mean and the Greek symbol sigma for the standard deviation. But it doesn't matter. It's data value minus the mean divided by the standard deviation. In this case, I always use the upper one. So 6.15 minus the mean, right here, 3.71, divided by the standard deviation, 1.22. That equals 2. Okay? That means that 6.15 is 2 standard deviations above the mean. Because of the way these work, you do it for 1.27, you're going to get a minus 2. It's the way they all work. You can use either one. So now this 2 here, 2 standard deviations above the mean, that means we're 2 standard deviations away from the mean, or in other words, our k equals 2. So 1 minus 1 over 2 squared equals 1 minus 1/4 equals 3/4. Now, for most of these questions, we'd be done. Sometimes they'd ask us for the fraction. Sometimes they might ask us for the decimal. You'd have to say 0.75. But for this one, they say they want the minimum number of eruptions. Well, at least 3/4 of them is what we've just found. So we take 3/4 times our total number of eruptions here, right, of 36. That equals 27. That's the answer for this one. All right, let's look at the next kind of question I wanted to show you. Okay, it's an empirical rule question. And really, the thing that causes trouble here is that the graph that they give us to describe the empirical rule is kind of missing something a little bit. Maybe I should say it's not clearly labeled. That's probably a better way of putting it. All right, so what we've got here is between 1 standard deviation below the mean and the mean, 34% of the data is in there, right? Between the mean and 1 standard deviation, they're using S, right, for the mean. Above the mean, 34%, right? Between 1 standard deviation above and 2 standard deviations above, another 13.5%, right? You see how this is going? Between 2 standard deviations above and 3 standard deviations above, another 2.35% of the data. Okay, well, up here they kind of group it like, right? Between 1 below and 1 above, or in other words, within 1 standard deviation, 68%. Right? Between 2 standard deviations below and 2 above, or in other words, within 2 standard deviations, 95%. And then the same thing out here, within 3 standard deviations, 99.7%. So here's the thing that's not clear. 99.7% is not all the data, right? All the data would be 100%. So there's 0.15% of the data out here beyond the mean plus 3 standard deviations, and 0.15% of the data out here below below the mean minus 3 standard deviations. Some questions that won't come into play, but some of them it does. All right, now let's answer the question. Heights of men on a baseball team have a bell-shaped distribution with a mean of 174 centimeters and a standard deviation of 8. Okay, so this time it looks like I'm calling it a population, but remember, it doesn't matter if it's the mean is the mu or the x bar, if the mean is the sigma or the s, right? Just depending, the mu and the sigma if it's a population, the x bar and the s if it's a sample. These formulas all work the same either way. All right. Using the empirical rule, what is the approximate percentage of the men between the following values? All right. So for part A, between 100 and x between 158 and 190. I'm going to do the same thing here. We'll use Z1 for the lower. It is going to be x minus the mean over the standard deviation. So that's 158 minus 174 over 8 will equal minus 2. And then for Z2, that will be the higher number here in the range they gave us. So that will be 190 minus 174 over 8. That's 16 over 8, and that's positive 2. What percentage of the data lies between 2 standard deviations below and 2 standard deviations above the mean? Well, between 2 below and 2 above, right, that's in here, right? Between 2 below and 2 above, that's plus or minus 2. So you could go through and just add up all 4 of these things, but they've already given that to us, right? 95%. That's the answer for that one. All right, so for B, we want greater than or equal to 166, less than or equal to 182. So the lower z-score, 166 minus the mean of 174 over 8 will be minus 1. And the higher z-score of 182 minus 174 over 8 will equal 1. So between minus 1, one standard deviation below the mean to 1 standard deviation above, so that's within 1 standard deviation of the mean, right? So that's our 68% answer right here. Or you could get it, you can just add up the 2 here. Either way, 68%. Now, one thing about the empirical questions that's different from the Chebyshevs is they don't have to make the match. Like the 2 values here were 2 below and 2 above and 1 below and 1 above. They don't have to do that, and they don't always. For example, they could ask you this: what percentage of the data is greater than or equal to 182 centimeters? All right. So that would be x greater than or equal to 182. We've only got one z-score to do here, right? So z equals 182 minus our mean over our standard deviation. It's going to be 1, just like it was in part B. So what percentage of the data is more than 1 standard deviation above the mean? Well, here's the mark for 1 above. More than 1 above would be all this out this way, right? So we're just going to add up each of these. So 13.5% plus this next one is 2.35%, plus the last one here, 0.15%. You add all those up, you get 16%. That is the answer to this question. And that is the end of part 2 of our video. I hope you found it helpful.